Hello class, today we're on lesson number 2 in chapter 11 and we're going to start working with algebraic fractions. Now if we look over here at the top of our page of 506, we see here some Hindu Arabic numerals, and we'll read, "It took a long time for Hindu Arabic numerals that we use to write numbers to be accepted throughout the world. The author of a popular arithmetic book published in Germany in the 16th century used Roman numerals because he thought his readers would find them easier to understand." Now this excerpt from this book shows how fractions were represented in it. You can recognize that there are 4 fractions on the left. We have 1/4, 6/8, 9/11, and 20/31. In Lesson 1, we received 2 ways to interpret fractions and learn how to transform each given fraction into other fractions that represent the same number. So we had equivalent fractions, such as 1/2 is equal to 2/4. Okay? Now, the table below shows, for example, how the fraction 1/4 can be transformed into other fractions equivalent to it. So we can take a fraction, and if we multiply both the numerator and denominator, okay, by the same number, we can change the fraction but keep the same value. Okay, so we see, for instance, we have 1/4. And let me go up here, get my pen, and we can start working here on our board. I need to get my white pen, make sure I got the right thickness. Okay, so if I have 1/4, okay, I can multiply both numerator and denominator by the same number. And in essence, what I'm multiplying by here is 1, because if I were to say multiply by 2/2, okay, I'm multiplying both numerator and denominator. I'm multiplying it by 1, so I'm not changing its value, but I am changing the fraction, and we'll see that what we have here is 2/8. Okay? And we can see the example as it goes on. When we multiply by 3, that would be 3/3, or 10, which would be 10/10. We will change the fraction, and you can see the corresponding result below. We have 3/12, 10/40, 25 100ths, and I'd like to just pause there and think about it. What do we know that is 25 100ths? Something that we deal with probably every day or very often, let's say. 25 hundredths is 1/4. But we think of 1/4, but I'm talking about 1/4, okay? Which is 25 cents. Alright? Which is 25 of 100. 25 cents would be 25 100ths, or 25 pennies. We know that 100 pennies equals $1, right? So this is 25 cents. We call it a quarter, okay? And it's a quarter of $1 is what it is. Okay, and you could see we can also do this with negatives. We have -1 and -5, and it does change these fractions. If you have -5 over -20, well, first we know that there are 2 negatives. So 2 negatives, you're dividing 20 in -20 into -5. We know that that becomes positive. So what we were doing here is just simply multiplying by -5 over -5, and we know -5 over -5 is equal to 1. So we did not change the value. Okay. Now, looking at the top of page 507, all of the fractions that result are equal. Each one has the decimal form of 0.25. And again, if we were writing values in decimal, and if you had $7.25, you would write what? 7.25, right? You'd have $7.25. So you can see how the decimal and the fraction are the same. It just depends on how we're going to express it and for what use. You wouldn't necessarily walk into a bank and ask for a fractional form of money. You would always use, so you wouldn't write on the slip, give me 7 $1/4. You would use 7.25 because we use the decimals. Now, in general, if n is not equal to 0, then NA over NB is equal to A over B. Now let's just take a quick look at that. Why are we saying that? Well, we have N over A. I'm sorry, I keep repeating that. NA, sometimes things get stuck in your mind. NA over NB, and we know that what we have here would be the same as this expression of n over n times a over b, right? This is the same thing, and we know that this is equal to 1, okay? Therefore, we could say this is 1 times a over b, and then we simply wouldn't use the 1, we would just say a over b. Okay, so we know that we can use this. This is sort of a form of elimination. We've gotten comfortable using this eliminating things that are in fractions that are factors. Be very careful. Do not do that with terms when you're adding and subtracting terms, unless that in itself is a factor. Then you shouldn't touch it. We're going to get into that a little deeper into this chapter, where we will have maybe x plus 1, but it's a factor because it's being multiplied by maybe x plus 2. So we'll go into that a little deeper. But when we recognize that we have factors that are the same in the numerator and denominator, we can actually eliminate them. Okay. Now, we have already observed that this principle can be used to reduce a fraction by dividing its numerator and denominator by the same number. Now, in this lesson, we will apply these ideas to the fractions of algebra. Fractions that contain one or more variables in their numerator and or denominator. So we can have x over 2, we have 5 over x, and we have 3x over x plus 1. Now, the denominator of a fraction cannot be allowed to be 0. That's something very important. You can never allow your denominator to be 0. We've already discussed that. We discussed the fact that you could never divide by 0. So you'll see from time to time it'll be mentioned. For instance, if I'm looking at that 3x over x plus 1, where we know that x could never be negative 1. It could never equal negative 1 because that would make the denominator 0. Okay, now, so thus, when we write the fraction such as 5 over x, x may be replaced by any number except 0. And again, for the same reason, the fraction 3x over x plus 1, x may be replaced by any number except negative 1. The only difference between algebraic functions and the functions of arithmetic is that algebraic functions contain one or more variables. So that's the only difference. It's that they're just variables. We will treat them the same way as we treat fractions. And again, I know that fractions are generally a challenge for most people. It's not as simple as just looking at numbers with the restrictions, or without these restrictions that we have when we're dealing with fractions. If we're just looking at whole numbers, and when we multiply, divide, and do all of our wonderful math, once we see a fraction, we know that there's a limitation, because that bar, that division bar, means something, and it has a major implication, particularly when we're dealing with algebraic expressions. Okay, so let's just read on. Their algebraic properties are identical. This means that algebraic fractions, like the fractions of arithmetic, can be transformed into equivalent fractions by multiplying or dividing their numerators by the same number. So if we look at 3x, let's just take a quick look here, get my pen back. We have 3x over x plus 1, and then we have 6x over 2x plus 2. And I will tell you that these are the exact same fractions. Well, they're not exactly the same because you're looking at two different things. But we can see that we can factor out of 6x. What can we factor out? Well, we know that this is 2 times 3, right? And over here I have 2x plus 2. We learned how to factor out this 2 and write 2 times x plus 1. Okay, it's that reverse distributive rule where we're pulling out the 2. And if you look at this, well, what is 2 times parentheses x plus 1 and parentheses? Well, that would be 2x plus 2 if we multiplied it out. So we've done that. So what are we looking at now? Well, we're looking at 2 times 3 times x, let's just say. And what are we looking at under here? We're looking at 2 times x plus 1. So, well, let me just put that little times there just so you can really see it. But now, what do we have? We have 2 over 2, and they're both factors. They're being multiplied across here. So we can say, hey, let's pull that out, and what do we end up with? Well, we end up with 3x over x plus 1, which is exactly what we have over here. Okay, so they are equivalent. One of the things that you're going to really need to learn now is how to simplify these algebraic fractions. A lot of times you can have a very complicated fraction, and when you start pulling the factors apart, you're going to start realizing that there's a lot of noise in there. It's just a lot of numbers with variables, and when you start factoring, you will realize that even though this looks much more complex than you probably wanted it, it's really something as simple as maybe, you know, x over 2. Okay, so you'll see some examples as you go on, even as you do your homework. Now, whenever the numerator and denominator of an algebraic fraction have a common factor other than 1, both numerator and denominator can be divided by that factor to get a simpler fraction. Now when we talk about divided by, we're basically doing this. This is what they're saying, okay? They're basically giving you these two being eliminated. When you cross out, that's what they're saying. So don't get too confused with that. I mean, in essence, it is what we're doing, okay? But just don't get too confused with that. Let's see. Now, we have, just reading on, like the fractions of arithmetic, an algebraic fraction is said to be reduced to lowest terms when its numerator and denominator have no common factor other than 1. So, we have this fraction, 3x minus 6. Let's write that down over here. 3x minus 6. And we have 5x minus 10. Okay, now in this case we saw that we could pull out a 2, right? And that was great because we were able to eliminate. But over here you might say, whoa, I don't see common factors here. I see 3. I know I can pull a 3 and a 5. Well, that's not going to work. Well, let's take a look. Okay, we can turn over if you want on page 508. We'll see how they worked it out. But let's say we do factor this, and we see a 3 is found in both of these terms, so I can factor this and say 3 times x minus 2. Okay, I'm just doing these quickly in my head because I know that 3 times x is here, and if I pull the 3 out here, that's 3 times 2. So you know, I can always do this, right? 3 times x. So I have my common term of 3, and I'm left with x and 2. So it's 3 times parentheses x minus 2. Now, what happens if I do that down here? Well, I'm going to end up with a 5. Well, why are you taking me there? I'm not going to be able to do anything with this 3 and 5, huh? Well, let's see what we end up with. Well, we take out the 5, and we have an x. And we take the 5 out of here. That's 5 times 2, so that's minus 2. So now we have 3 over 5, but look what we have here. X minus 2 over x minus 2. And those can be eliminated, okay? Because it doesn't matter what you put in for x here. They'll always be the same. And that's really equal to 1. So you can say x minus 2 over x minus 2 is actually equal to 1. And always remember, again, that these are factors. You see this? Being multiplied. Now you might say, well, hold on, you're doing some adding, subtracting. Yeah, but this is all one expression right here, and you're taking the entire expression, which is part of, again, both numerator and denominator as factors. Okay, let's be very careful to not say, let's see, x minus 1 over x plus 2. Okay, you cannot do this. Okay, you cannot eliminate these two that way. Why? Because they're not factors, they're terms, they're being added. Okay, this is totally different. Over here we are seeing them as factors, so you have to get used to that. Okay, let's see, let's continue reading. And so we did reduce this to, I'm sorry, we didn't finish our problem there. Maybe I should just erase this so we can finish writing what the answer was. The answer to this was 3/5, right? Because we eliminated the x minus 2 factors, and we will end up with 3/5. So as you can see, going back to what I stated earlier, 3x minus 6 over 5x minus 10, oh boy, a lot of noise. What is that? It's really just 3/5. Okay, 3/5. That's all it was. And if you express that in terms of a decimal, that would just be 0.6. All right, 0.6. All right. So You're going to have opportunities, and as you do your problems, it's built into the problem. They want you to learn to find the factors. As you get deeper and deeper in math, it's going to get a lot more complicated, and maybe they're not going to be so easy. But right now, just try to learn how to find these factors, pull the puzzle apart, find these factors, and eliminate them. Let's just finish up our lesson here. When we divide numerator and denominator by their common factor, x minus 2, we're assuming that x is not equal to, guess what, 2. All right, why? Because, of course, x being 2 would put 2 minus 2 would create a 0 in that denominator, right? So the possibility that x is equal to 2 is ruled out by the original fraction. So something just to, you're going to hear it and you're going to learn it later. If you're dealing with fractions and you have a variable in the denominator, it will always limit what your answers could be. Obviously, you could not allow things to become 0. Now, because its denominator 5x minus 10 cannot be 0, x cannot be equal to 2. When we write 3x minus 6 over 5x minus 10 is equal to 3/5, then it is understood that the two fractions are equal for all values except 2. So even though we came out to 3/5, we have to go back to the original problem and say it's 3/5, but only if x is not equal to 2. So that's kind of just a little extra, because you always go to the original, because you look at 3/5 and you say, well, that's just a simple fraction. That means it's 3/5 under all circumstances. Well, in all circumstances except when x is equal to 2. All right, so we have a couple more examples here. We can see here that they write a fraction that is equivalent to 8 over x and has a numerator of 8x. So what do? Well, they simply multiplied both the numerator and denominator by x over, x, which would be x over x. And again, remember, when you multiply anything by a fraction such as, whereas the numerator and denominator are the same, remember, you're always multiplying by 1, so you're not really changing the value. So what is the answer? Well, the answer would be 8x over x squared. So you were told to write an equivalent fraction to 8 over x that has a numerator, which is the top, of 8x. So now it's 8x over x squared. And again, you're going in one direction. You're adding, so to speak. You're creating, not adding. I don't want to use that term mathematically, but I'm saying is that you're making the expression more complex. You're seeing 8 over x become 8x over x squared. Later on, you're going to want to be able to do that reverse, and that ultimately is where we're heading. We want to be able to reverse this, pull out common factors, and say, well, 8x over x squared really is just 8 over x. And here we're going to reduce the fraction x, and then example number 2, x minus 1 over x squared minus 1 to lowest term. So now we're doing the reverse. Now we want to see, well, what are factors here? And if we remember, remember the forms that we learned, and we learned how to factor these polynomials. And in this case, we have a binomial, and we have two squares, the difference of two squares. Well, how do you express the difference of two squares? Well, we're going to see it here. Now, factoring the numerator and the denominator in this fraction, we're going to get, look at 1 times x minus 1. Now, they threw the 1 in there for a particular reason, and you're going to see why. But then, if we factor x squared minus x, well, again, this is where we learn the difference, the difference of two squares. We have x plus 1 times x minus 1. And when we do that, well, we have the common factor of x minus 1, so we eliminate that, and that's why we had that 1 there, because we need to leave something at the top, and 1's always there, okay? So it will be 1 over x plus 1. Now, now look how much simpler it is to recognize what this fraction is. Rather than x minus 1 over x squared minus 1, we can simply look at 1 over x plus 1. Much easier. And again, if we divide the numerator and denominator by x minus 1, we have to assume that x is not equal to 1. That's a limitation that we have, okay? And if we keep reading on, if it were, we'd be dividing by 0. The possibility that x is equal to 1 is ruled out by the original fraction. Because its denominator, x squared minus 1, cannot be equal 0, x cannot equal to 1, okay? And now we can also add to that, and I'm not quite sure why they didn't, that we also can say that x cannot be equal to negative 1. And the reason is because if we put negative 1 and we square it, we'd have 1 minus 1 the same. So really there are two. And if we looked at that one section in the middle here with x plus 1 and x minus 1, we can definitely see that x cannot be equal to negative 1. Now, let's just take a look at these last two examples. If possible, reduce the fraction of 2x plus 5 to lowest terms. Now, here we're going to get a little more complicated. Now, let's clear up our board. And you'll be able to take a look here. See how easy it is to erase and paint. So much harder on the chalkboard. Let's take a look at our problem here. We have 2x plus 5 over 2x. Now, they want us to reduce this to the lowest terms. Now, if we look at the factors, we really don't have much we can do here. It says the numerator of this fraction cannot be factored any other way than 1 times 2x plus 5. So we have that. This means that the numerator and denominator have no common factor other than 1. So we must leave this. You might think, well, I can factor, if this were a 4, I think we'd have a great opportunity because we could factor the 2 out. But really, we can only express this as 2x plus 5 times 1. And if this is 2x, or 2 times x, we don't have common factors. We have a factor of 1, we have 2x plus 5, we have a 2, we have an x. We have nothing that's common, so it's already reduced to its lowest terms. Now we're told here on example 4, change 3 over x and x over 6 to equivalent fractions that have the same denominator. Okay, so let's see. We have 3 over x, and then we have x over 6. Now, what do? Well, they simply multiply them. And by multiplying them, we can actually get a common factor, okay? So what would be the common factor here? We'd have 18. I'm sorry, when they multiply, I'm not multiplying the 2, they're multiplying the denominator. So let me just rewrite that. I'm sorry. The denominator, we have 3x plus 3 over x, and we have x over 6. So let's just do that. So for us to have a common denominator, we have to multiply these two, at least changing the fraction. Now we know we can only change a fraction if we multiply it by 1. So in the first case, we're going to take 3 over x and multiply it by 6 over 6, which is 1. And in the second case, we're going to have x over 6, and we're going to multiply it by the denominator here, x over x. Now notice what we're going to end up with here is 6x, and again 6x over here. So this will allow us, and we're only multiplying by 1. In both cases, we have x over x and 6 over 6. So we're going to multiply numerator and denominator by this denominator, and again do the same thing here, numerator and denominator. So what do we end up with? Well, we end up with 18 over 6x, right? And we end up over here with x times x, which is x squared over 6x. Okay, so those are the fractions with equivalent denominators, or the same denominator, let's call it. All right, so that is the end of this lesson, and we'll you can move on to your your homework. And again, you'll have probably some examples here in your homework that are going to challenge you to do more factoring. So you're going to have to recognize those opportunities, and then you can reduce your fractions.